In early 2025, astronomers spotted something unusual gliding through the darkness of space. A glowing visitor, not from our solar system, but from the deep reaches between the stars. They named it 3I/Atlas, the third confirmed interstellar object ever discovered. At first glance, it looks like a comet, a bright tail, a hazy coma, and a path that swings past the sun before heading back out into the void. But almost immediately, scientists noticed details that didn't fit the usual picture. Its chemistry is different, its behavior unpredictable, and its journey raises questions we are only beginning to explore. Some researchers call it a natural relic, frozen debris from a distant planetary system, carrying clues about how other worlds are built. Others whisper about stranger possibilities, from unusual physics to even artificial origins. What makes 3I/Atlas truly unsettling is not just what we know, but what we don't. Its speed, its path, and its mysterious makeup leave scientists with more questions than answers. Could it be harmless, just another comet from another star? Or is there something about this visitor that we should fear? When scientists looked closer at 3I/Atlas, the first surprise came from its chemistry. Most comets in our solar system are made largely of frozen water mixed with smaller amounts of gases like carbon monoxide or carbon dioxide. But 3I/Atlas does not follow that rule. Data from powerful telescopes, including the James Webb Space Telescope, revealed that this object is unusually rich in carbon dioxide. In fact, the ratio of carbon dioxide to water is far higher than what we normally see in comets closer to home. Traces of other molecules, such as carbonyl sulfide, also appear in its spectrum, adding to the puzzle. Why does this matter? Because chemistry tells a story. If 3I/Atlas formed in a different kind of planetary system, its strange mixture of ices could reflect conditions we have never directly studied before, perhaps colder regions or a star with very different radiation and heat. The unsettling part is simple. If interstellar visitors like this carry chemical fingerprints so unlike our own comets, it suggests that the universe builds worlds in ways we do not yet understand. And with that, 3I/Atlas forces scientists to rethink what they thought was familiar. As 3I/Atlas drew closer to the sun, astronomers expected it to remain quiet until sunlight warmed its icy surface. Instead, it became active, releasing gas and dust at distances where most comets stay frozen. Observations showed a coma of water vapor and icy grains, even while it was still far from the inner solar system. More surprising, the active surface area seemed unusually large. In many comets, only a few percent of the surface vents gas. For 3I/Atlas, early measurements suggest more than 20% may be erupting at once. This level of activity makes the object unpredictable. Jets of gas can push on the nucleus, slightly altering its path through space. Bright outbursts can change quickly, making it difficult to model how it will behave when it swings around the sun, and with its nucleus still hidden inside the haze of dust, scientists cannot even confirm its true size. The concern is not that it threatens Earth directly, but that it demonstrates how little we know about interstellar visitors. If an object can defy our expectations at a safe distance, what might a future one do when it comes closer? From the start, 3I/Atlas was marked by speed. It entered our solar system on a hyperbolic path, moving faster than the sun's gravity could ever capture. That alone confirms its interstellar origin. It came from another star system, and once it leaves, it will never return. But its exact journey raises problems. The object reached perihelion, its closest approach to the sun, on the far side, hidden from Earth. This meant that during its brightest and most active phase, our view was partly blocked. Key moments of its behavior may never be recorded in full detail. Adding to the challenge is its velocity. At tens of kilometers per second, it streaks past far too quickly for any spacecraft to intercept. Unlike comets born in our solar system, which sometimes allow decades of preparation for missions, interstellar objects give only months of warning before they vanish into the dark again. For scientists, the fear is not that 3I/Atlas poses a direct threat, but that we are largely powerless to study it up close. Its speed and path underline a hard truth. When interstellar visitors arrive, we may not be ready to meet them. Whenever an interstellar object enters our solar system, questions about its true nature quickly follow. With 3I/Atlas, some scientists have raised possibilities that sound extraordinary, even unsettling. Could it be more than just ice and dust? The idea of an artificial origin was first popularized with Oumuamua, the first interstellar visitor discovered in 2017. Its odd shape and unexplained acceleration led Harvard astronomer Avi Loeb to suggest it might be alien technology. With 3I/Atlas, Loeb and colleagues have again published a paper exploring similar questions. They point out that certain features, like its unusual chemistry and unexpected activity, leave room for unconventional interpretations. NASA and most of the scientific community stress that, so far, the evidence supports a natural explanation. Telescopes detect clear signs of volatile gases, dust, and a tail consistent with cometary behavior. The alien spacecraft label, while it captures headlines, remains unproven and highly controversial. Still, these discussions are not dismissed outright. They serve an important role, reminding us that interstellar objects can behave in ways we don't fully understand. And if even one object someday were artificial, it would change humanity's place in the universe forever. For scientists, the real concern with 3I/Atlas lies in the unknowns. Even after months of study, its nucleus remains hidden behind a glowing cloud of gas and dust. Estimates of its size range from just a few hundred meters to several kilometers across, a huge margin of uncertainty. Its chemistry also leaves open questions. While telescopes have detected carbon dioxide, water vapor, and other molecules, the exact balance of materials inside the nucleus is still unclear. A sudden outburst or fragmentation event could release more information, but it could also make the object unstable in ways that are difficult to predict. Another risk is observational. Because its closest pass to the Sun happened on the far side, scientists may miss critical data about how it reacts to intense heat. That means we might not fully understand its structure before it fades from view forever. None of this makes 3I/Atlas a danger to Earth. It is passing far from our planet, but its unpredictability highlights a larger problem. If a future interstellar object were on a closer trajectory, we have no tested plan for interception, study, or defense. For now, all we can do is watch and learn. 3I/Atlas is already fading into the dark on a path that will carry it out of our solar system forever. It leaves behind only the data we've managed to capture, fragments of chemistry, flashes of activity, and a trail of unanswered questions. Is it simply an icy relic, shaped in the cold of another star's nursery? Or does its strange behavior hint at something more, something we're not yet ready to explain? For scientists, the fear is not doom, but ignorance. Each interstellar visitor reminds us how much we don't know and how unprepared we are for the unexpected. As humanity builds new telescopes and considers missions beyond Earth, these objects are a call to action. They demand vigilance, curiosity, and imagination, because the next visitor may not pass us by so quietly. Stay curious, stay watching. The universe is only beginning to speak.